Okay, before we begin today's lesson, like I said, I forgot to show you how to do one type of problem yesterday. But then again, if you did your homework, then you figured it out, right? Or looked at the example or something. Problems like this. If cosine x equal 4/5, and x is between -pi/2 and 0, and sine of angle y equals 12/13, and y is between pi/2 and pi, compute tangent x plus y. There were several problems like this on last night's homework, yeah? There was homework last night. So the first thing you do is you apply the identity. So tangent of the first plus tangent of the second, all over 1 minus tangent of the first, tangent of the second. Are we starting to memorize these identities? Don't worry, Mr. Park, it's all memorized already. Because I believe the speed quiz is on Wednesday. Okay? Now, how do you figure out these values now? If the cosine of an angle is 4/5, is 4/5 like a number I'm supposed to know for cosine? No, the only numbers you're supposed to know are like 0, 1, √3/2, 1/2, and √2/2, right? So what do you do when it's like an odd number like this? You draw the reference triangle. So, reference triangle, if it's in the first, here, let's review. If it's in the first quadrant, you draw it here. Second quadrant, you draw it there. Third quadrant, you draw it here. And fourth quadrant, you draw it here. So it makes like a bow tie. Does that look familiar? So what quadrant is this if it's between -pi/2 and 0? Fourth quadrant. So you draw it over here in the fourth quadrant. The cosine is 4/5. So that means adjacent over hypotenuse. You guys know SOHCAHTOA, right? Adjacent over hypotenuse is 4/5. Just remember the hypotenuse is always positive. And then using the Pythagorean theorem, what is this going to be? -3, because you got to go down. You got to put the proper signs on. And then for this reference triangle, if you're between pi/2 and pi, what quadrant is that? Second quadrant, so draw it like this. Okay, so this is angle x, here's angle y. It says the sine is 12/13. So that means opposite over hypotenuse is 12/13. And then using the Pythagorean theorem, what would this be? -5, because you got to go to the left. Anytime you go down or to the left, that's going to be negative now. So how do you compute what tangent x is? You look at the reference triangle. Tangent is opposite over adjacent. So that would be -3/4. Okay, plus tangent of angle y right here. Opposite over adjacent. -12/5 all over 1 minus -3/4 times -12/5. Once you write this down on your paper, the most you can lose is 1 point. Because that's just computation, right? Because when you take the AP exam next year, that is full credit. You don't have to simplify any arithmetic at all. But I expect you to for 1 point though. Okay, I'll leave the computation to you. So, expect a lot of problems like this. And every time you miss a sign, that's not just a 1 point error now, that's a 2 or 3 point error. So make sure you draw it in the proper quadrant. Okay, so today we're just learning the rest of the identities, the double and half angle identities. I'm not going to derive all of them, I'll just derive a few of them just so you can see how it's done. So cosine 2x. Now actually there's 3 identities for cosine 2x. So on the speed quiz, you got to write all 3 now. Did I tell you guys last year somebody wrote the same one 3 times? You're only going to get credit for one of them. You got to write all of them now. So how do you, like, what if you're on the quiz? I'm giving you 10 seconds of problem now. So some of you can actually derive it in that amount of time. So you guys remember how to derive that from last year? Yeah, 2x is, let's do it over here. Cosine 2x isn't that the same thing as cosine x plus x? And then now we can apply the identity we learned last time, right? Cosine of the first, cosine of the second, plus or minus? Minus sine of the first, sine of the second. So isn't that just, here, just write it over here, right? Cosine squared x minus sine squared x. Easy. Now, how do you get the other two? Let's make more room here. Well, if you want to change everything to cosine, then what do I substitute for this? 1 minus cosine squared x. So if you distribute the minus sign, what are you going to get?
2.
Here, I'm going to put the parentheses there for you. 2 cosine squared x minus 1. And then if you want to derive the one that has the sign in it, then what you do is here, you substitute 1 minus sine squared x, and you get 1 minus 2 sine squared x. But in reality, you want to have these memorized. They should be at the tips of your fingers. Sine 2x, same thing. You would go sine x plus x. Apply the identity. Sine of the first, cosine of the second, plus cosine of the first, sine of the second. Gorilla plus gorilla is 2 gorilla. And tangent 2x, you can do the same thing. Just go tangent x plus x, and you will get 2 tangent x all over 1 minus tangent squared x. I don't want to derive all of them. The main thing is I want to show you how to do problems. Okay, so these are called the double angle identities. Now, what about the half angle? So we need to fill this in. Equal, equal, equal. There's 3 for that. Okay, I'm just going to do one of them. I'll do the first one. Cosine x over 2. Well, to derive the half angle identity for cosine x over 2, you're actually going to use the double angle identity. Okay, so watch. Cosine of 2x is equal to 2 cosine squared x minus 1, correct? Right here? Okay, now solve for this. So cosine squared x is equal to, add 1. How do you solve for this? Add 1.
1 plus cosine 2 x all over squared.
And then divide by 2. So all you're doing is taking that identity and solving for cosine. Now square root both sides. Cosine x equals, what happens when you square root both sides? Plus or minus the square root of 1 plus cosine 2x over 2. And where does the plus or minus come from again? The absolute value. When you square root this, you get the absolute value of cosine x. Anyway, do you notice that this angle here is just double that one there? See, this is 2x, that's x. So now we have cosine x over 2, so that means whatever angle you put here, that angle there is going to be double what it is. So this is going to be plus or minus the square root of 1 plus cosine, what's double this? X over 2. That's how you derive the half angle identity. You derive it from the double angle identity. Did you guys do this last year, or your teacher just said memorize it? You guys don't even remember. Anyway, this one is plus or minus the square root of 1 minus cosine x over 2. And then, of course, once you get these two, how do you get tangent? Just go sine over cosine. Just go this over this. So what is this over this? Plus or minus the square root of, when you go this over this, the 2's cancel out and you get 1 minus cosine over 1 plus cosine. But there's 2 others. You know what, I'm just going to write them down. Some of you are writing this down. It's on the identity sheet. It's the first thing on the PDF. 1 minus cosine all over sine. You can get this one by inside the radical, you just simply multiply by 1 minus cosine x. If you just multiply top and bottom by that, because look, gorilla times gorilla gonna be gorilla squared, right? That's gonna come out of the radical, it's absolute value of gorilla, that's this. And then when you multiply this times this, you're gonna get 1 minus cosine squared x, which is sine squared x, and that comes out as an absolute value of sine x. But we can actually take the absolute values away, because what you have to do is you gotta check quadrant by quadrant. I'm not gonna do that now, but if you check it, you don't need the absolute value. That's what you get. And then the third one is this, sine x all over 1 plus cosine x. And there you go. These are all the identities you need to know. Anything is fair game on the speed quiz. Okay, but then on the quizzes and the tests, you gotta know how to use them. The speed quiz is just to see if you know it. Okay, so what kind of problems can you expect to see? Okay, let me think. Compute. I don't want it to be the same as the homework. Yeah. How about cosine 7 pi over 8? Now, I'm sure you learned last year that anytime you have pi over 8, you have to use a half angle identity. If it's over 12, then you can use either half angle or the sum or difference identity. But when it's pi over 8, you can't write that as a sum or a difference. So we're going to use half angle. So here we go. This is equal to cosine of, now is this half of an angle that I know? 7 pi over 4. That's right. Okay, so all you gotta do now is apply that identity right there. So this is equal to plus or minus the square root of 1 plus cosine x all over 2. Right? It's right there. You gotta have it memorized though. Okay, now what do I do with this plus minus? Just leave it there? What did you guys remember? Anything about, what do you do with that plus or minus? You have to figure out which one it is. 50-50 chance, just guess. Don't just leave it though, because how can the cosine of an angle be plus or minus? It's either one or the other. You gotta commit to one, and how do you figure it out? You have to know the quadrant of that angle. Where is 7 pi over 8? Okay, here's the unit circle. Here's pi over 2, this is 4 pi over 8. This is pi, which is 8 pi over 8. So shouldn't 7 pi over 8 be somewhere in between? Yeah, it's over here somewhere. It's in the second quadrant. So cosine in the what is the cosine of a second quadrant angle? Negative. So that's how you pick the sign. You got to know the quadrant of this angle. Believe it or not, that sign is worth 3 or 4 points, you know. You got to get that right. And then now you just got to know your trig values. What is the cosine of 7 pi over 4? Okay, now think ahead. Is it better to write 1 over root 2 or root 2 over 2? Because you're going to have to simplify your answer for 1 point, you know. Root 2 over 2 is better. How do you know, Mr. Park? Well, you got to kind of look at the steps that are ahead of it. You got to have foresight. I don't have any foresight. Okay, how do you simplify this? Inside the radical, multiply top and bottom by the LCD of all fractions. 2. Hopefully after a while you don't even have to write that down, you just do it. So on the top you're going to get, multiply this by 2. Multiply that by 2. Multiply that by 2, you get 4, but the 4 comes out of the radical as 2. And there you go, that's your answer. Pretty neat though, a lot of 2's there. So that's how you use the half angle. Okay, I'm going to erase this already because we need the space. Let's do a tangent one. Compute the tangent of, give me something over 8.
3 pi.
Huh?
3.
3 pi over 8, okay. Okay, so is this equal to, here, let's just do it going downward. Is 3 pi over 8 half of an angle that I know? Yes, 3 pi over 4. Okay, now, tangent of x over 2 has 3 identities. Okay, I'll write them again. Here they are. Plus or minus the square root of 1 minus cosine x all over 1 plus cosine x. 1 minus cosine x over sine x. And sine x all over 1 plus cosine x. Which of these is the bestest to use? A, B, or C? How many people say A? Good, because that's the worst one to use. Because look, you got a radical, you're going to have to simplify that, and you got to figure out whether to use the plus or minus. These two don't have plus or minus. That means you don't need it. So it's one of these two, either B or C. How many people say B? How many people say C? Yeah, you have to vote once, you know. Okay, the answer is B. You know why? Because you only have one term in the denominator. So if it's a radical, you just multiply, like if this is radical 2, you just multiply top and bottom by radical 2. But over here, if you have 1 plus radical 2, then you got to multiply by the conjugate. It's more work to simplify. This is the best one because it has a single term in the denominator. But it's up to you. You can use any one of these three. It's going to come out to the same thing. But I'm going to use this one. So tangent of theta over 2 is 1 minus cosine theta all over sine theta. And then you just got to know your trig values. Okay, now, is it better to use 1 over root 2 or root 2 over 2? Now, it really doesn't matter. But you can save a step if you just pick like the most efficient one. What do you think? This one is 1 over root 2. So what is cosine of 3 pi over 4? Negative 1 over root 2. Sine of 3 pi over 4? 1 over root 2. Now multiply top and bottom by root 2 and you get root 2. Multiply this by root 2. Plus 1. Multiply that by root 2. Over 1. There's your answer. It's a pretty nice answer. Whereas, here, let me show you. Some of you don't know what it's like. What if you had 1 minus negative root 2 over 2 all over root 2 over 2? Then you got to multiply top and bottom by 2 then, right? Multiply that by 2. Multiply this by 2. Multiply this by 2. Now that's correct, but you got to simplify it. This is not simplified because you can factor out a root 2 on the top and get root 2 plus 1 over root 2, but then these cancel out and you get that. Mr. Park, I'll take the minus 1. Okay, that's how we use half angle identities. What about double angle identities? Well, if you look over there, you gotta recognize your double angle identities. Okay, let's start off with an easy one. Compute the following. No, you know what? Let's just start with the harder one there. How about sine pi over 8 times cosine pi over 8? Well, one thing we could do is we could compute this using half angle identity, do all this work. Then I can compute this using a half angle identity, so do some more work and then multiply these two answers together. Yeah, you can. Or you can go, A, use somebody. Or how about this? A, you almost somebody. What's missing here?
2.
The 2. Mr. Park, if that was a 2, I'm in the money. Well, how about just put the 2 there and then put a 1/2 outside there? Because then, right, 1/2 times 2 is 1. This is the original problem. That's called lomi again. And then, you somebody. What is the identity for 2 sine theta cosine theta? Here, let me write it for you. I don't know what you're talking about, monsieur. I'm talking about this one. Except, see, we have this. We're going backwards to that one. So, 2 sine theta cosine theta is sine of 2 theta. So if this is theta, what's 2 theta? Pi over 4, and hey, that's a number I know.
Root 2.
Well, I know it, do you know it?
Root 2.
Root 2 over 2, so your final answer, root 2 over 4, boom. That's a lot faster than using two half-angle identities. That's craziness. Okay, let's do another one. That's why these identities have to be at your fingertips. Okay, here we go. Sine squared pi over 12 minus cosine squared pi over 12. I hope I'm not doing the exact homework problems. So we can compute sine pi over 12. We can either use a sum or a difference identity, or we can use a half-angle identity, or we can go, hey, you almost somebody. See, but if you don't know your identities, how are you going to recognize? How are you going to pick up your uncle from the airport if you don't know what he looks like? Or he going to text me on the phone? Yeah, but still, got plenty of guys there. How do you know which one it is? Okay, I'll tell you which identity you're supposed to be looking at. Cosine squared, no. Cosine 2x is equal to cosine squared x minus sine squared x.
Factor out a -1.
Doesn't that look like this? Yeah, but Mr. Park, it's the wrong way. Well, how about factor out a negative sign then? Cosine squared theta minus sine squared theta. Right there. So, this is the identity for cosine 2 theta. So if this is theta, what is 2 theta? Pi over 6, and I definitely know that. So there's your answer, negative root 3 over 2. You gotta recognize identities. That's what those problems are right there. And then you're gonna be drawing some more, what do you call, reference triangles? Okay, let's do that. Okay, I'm gonna give you a hint. I love to use this one. Okay, let me think of one where you gotta figure out the quadrant. Let me think. Okay, here. If cosine, I'm trying to concentrate here. No. If x is between pi over 2 and pi, wait, let me think. No. Pi and 3 pi over 2. Yeah, that's what I'm talking about there. And tangent x is equal to negative 24 over 25. Compute, I'm trying to make the problem come out nice. Compute the cosine of x over 2. Okay, you're gonna get problems like this on the quiz, guaranteed. The only things that are gonna change are the numbers and different identity, but you do it the same way. Okay, so the first thing you do is you regurgitate the identity. What's the identity for this? Really? Plus or minus the square root of 1. Don't worry, Mr. Park, I'll get it by next Wednesday. Did I do it correctly?
Yes.
Yeah, okay. First step, now you gotta figure out which one to use. Now, if you don't know, then just guess, because if you leave the plus or minus there, that's gonna be more points taken off. So we have to know the quadrant of this angle right here. Do we?
No.
Oh, yes, we do, because look, this is what's given. Yeah, but Mr. Park, this is x over 2. Well, that's x. What can I do to x to get x over 2? Divide by 2. So take this inequality and divide through by 2. So x over 2, x over 2 is between pi over 2 and 3 pi over 4. Oh, so if this angle is between pi over 2 and 3 pi over 4, I'll draw it. Between pi over 2 and 3 pi over 4, that means right there. Isn't that second quadrant? What is the cosine of a second quadrant angle? Negative. This sign is big points, you know. You gotta figure it out. But if you can't, just guess. Come on, we're honors, we can figure it out. Now, what do I substitute for cosine x? You gotta draw the reference triangle for this. Okay, well, x is between pi and 3 pi over 2, so what quadrant is that?
Third.
Third quadrant. So you draw the reference triangle in the third quadrant like this. Tangent is negative 24 over 25. So what is tangent again? Opposite over adjacent. So 24 over, oh, wait a minute, sorry, can I change that? I meant 24 over 7. I don't know what I was thinking in my head. 24 over 7. Oh, and then Pythagorean theorem?
25.
7, 24, 25. You can bet I'm going to use a multitude of Pythagorean triples. But then didn't we learn almost all of them? Oh, there's an infinite number. We learned a lot of them when we did logic, right? We're supposed to remember them. Well, if you don't, then just figure it out, right? Pythagorean theorem. Is that the correct reference triangle? No, this is minus, because you got to go down. And also this one is minus as well, because you got to go left. Each minus sign is probably 2 points now. Okay, so look at this picture. What is the cosine of angle x? Here's angle x here. What is cosine? Adjacent over hypotenuse, negative 7 over 25. Question?
Wouldn't tangent of x have to be positive then?
You're right. You're right. That's what happens when I try to do it on the spot nowadays. Everybody, you guys understand what he was talking about? Because it's third quadrant is supposed to be positive. All right, so we fixed that. Okay, anyway, so you write this on your paper. You get everything except 1 point. You want that 1 point, you gotta simplify this. But see, when I write problems, I try to make them come out somewhat nice. And this one does. Can we do this in our head?
Yeah.
Well, let's try. What is 1 minus 7/25? Maybe not. Huh?
18.
18/25 divided by 2. 9/25. Square root. 3/5. See, I was trying so hard to make it come out. It's not easy to make it come out nice, you know. Okay, so look, I guarantee you this problem's on the quiz. Guarantee. You know why? Because there's so many things going on. Not that you just have to know the identity. You got to draw reference triangles and you got to figure out the quadrants and everything. Okay, what's another problem that'll come up? Let's see. Oh, solving equations. Okay, let me do one that's not on there. Okay, here we go. Solve for x. And only between 0 and 2 pi, yeah? Cosine 2x equal cosine x. I believe that's not up there. Yep, okay. What do I do? What are we learning in this section? Double and half angle identities, huh? Look, cosine 2x. You're going to replace it with the identity. Which one? There's 3 of them. Okay, let me write them down again. Cosine 2x equal cosine squared minus sine squared, or 2 cosine squared minus 1, or 1 minus 2 sine squared. Which one do I use, considering that that's a cosine?
The second one.
The second one. You want to make everything just one trig function, right? So 2 cosine squared minus 1 equal cosine x. What happens if you use a wrong identity? Fatal error. Wrong identity equals fatal error. That's why I told you guys, if you don't memorize your trig values and the trig identities, you will fail the last 3 tests of the course. It's just a fact. It's a fact. Okay, so it's up to you if you want to do it or not. Hey, it's a quadratic equation. So you make one side 0. If you want to do u substitution, you can, but I think at this stage we don't need to already. And it factors. Just think about it. If I'm not going to let you use a calculator, it has to factor, right? It has to. 2 cosine, 1 and 1, minus plus. Did I do that correctly? Yes, because I'm the teacher. So cosine x is either equal to negative half or 1. And these are all numbers you're supposed to know for cosine, right? So cosine of what angle is negative half? Are you guys actually practicing this?
2 pi.
Not in school, Mr. Park, only in my room at home. Whatever you gotta do. So what is that?
2 pi over 3.
2 pi over 3, 4 pi over 3. Cosine of what angle is 1? 0 and 2 pi. Do we have to include 2 pi?
Yes.
Well, let me look. Yeah. Now, most books, they only ask you for this. But I'm telling you on the AP exam, it's that. That's why I'm trying to train you for that. And again, see why if you don't know your trig values, how you gonna even get these numbers? And you gotta get them quick, you know. Because you know what's coming up after this, right? Inequality. What if instead of an equal sign, what if there was like a greater or a less than? How do you solve inequalities? In fact, let's just do one now. Because no, it's going to be on the quiz. It will. Okay? So instead of an equal sign, which one do you want to do? Greater than or less than? Pick one. Doesn't matter to me. Greater, okay? Let's pick greater than. So you make your number line. You put these numbers on the number line. And then you test. That's how we do number lines, right? Think of a number between 0 and 2 pi over 3. What would be a good number?
1.
Pi over 2 is good. You know why? Why is it good to pick quadrantal angles? Because sine and cosine are either 0, 1, or negative 1, right? That's it. So pi over 2 would be good. Now plug it into this thing right here. Cosine of pi over 2 is 0, right? 0 plus 1 is positive. If you need to write it down, 0 minus 1 is negative. What's positive times negative? Negative. Oh, and then just alternate the sign because we've got odd powers. No, it doesn't work like that. Only if that was like u or x or something. Then they would alternate. But I don't know if you guys learned this last year. When you have non-polynomial functions, there is no pattern. Which means you have to test every region separately. Does everybody understand? There is no pattern. Okay, how come every year then about 1/3 of the students just alternate it? Because you guys forget. Okay, what's a good number to plug in here?
Pi.
Pi, good. Cosine of pi is -1. So -2 plus 1 is negative. -1 minus 1 is negative. Negative times negative is? Mr. Park, it's alternating. But that's just luck. I'm telling you it is now. What's a good number to plug in here? 3 pi over 2. Cosine of 3 pi over 2 is 0. 0 plus 1 is positive. 0 minus 1 is negative. Positive times negative is negative. Mr. Park, it alternated. It's just luck. I'm just warning, I'm saving up the ones that don't alternate for the quiz. Just believe me. Question?
Oh, can I go with that?
Mm-hmm. Okay, so what's the answer? We're looking for greater than 0. That's the plus sign, so your answer is 2 pi over 3 to 4 pi over 3. Inequality is just like an equality, except you just got to test the number line. That's the only thing. You just got to do more work. Okay, 1 or 2 more problems and we're done. Maybe you might have time to play a game today. I don't know. Oh, look, you got some proof-like problems. I'll leave you to that. Okay, here we go. I'm going to do something like number 6. So cosine 3x, I'll do cosine. Did you guys derive the triple angle identity last year? I'm pretty sure you did. I saw it in the book. Now, of course, math team people, we just look at that and we just write down the answer. 4 cosine cubed x minus 3 cosine x. If you want to do math competition, there's certain things you just have to know. So like on the math team, we memorize triple and 4-pole angle identities. Okay, but the rest of us, what do we do? How do I derive an identity for cosine 3x?
Cosine 2x.
Exactly. You change it to 2x plus x. And then you expand it. Cosine of the first, cosine of the second, plus or minus? Minus sine of the first, sine of the second. See, that's why. If you don't have your identities at your fingertips, these kinds of problems are almost impossible. And then you have no idea what's in store for you on the test. Just believe me. Okay, so if I want to write this only in terms of cosine, how do I change everything to cosines? Well, cosine 2x, there's three identities. Which one do you think I'm going to use here? 2 cosine squared x minus 1, the one with the cosine. And then sine 2x is 2 sine x cosine x times sine x, that would be sine squared x. Now, the only thing that's not cosine here is this. So what do I do with that? Is there a way I can change sine squared into cosine? Yeah, 1 minus cosine squared, the Pythagorean identity. All you have to do now is just multiply it out. Okay, let's multiply it out. Distribute. And then negative 2 cosine x distributed here. This is just algebra, you know. Okay, so what do we have? 4 cosine cubed x minus 3 cosine x. There you go, triple angle identity. Now tonight you got a fourple angle identity over there, number 7. Oh, I'm looking at 8, 9, and 10. You know what? We don't have time for games today, sorry. We gotta learn that still yet. Okay, so tonight's homework, I'm not gonna do it for you, I'm gonna start you on it. Cosine 4x. Now there's actually an infinite number of things you can do. But the two most common ways would be to either go 2x plus 2x, or the more sophisticated 2 times 2x. See, cosine 2 theta. So which one do you think you're going to do? I'm not going to tell you what to do, but I'm going to tell you right now, this one is better. It's way faster. But you got to learn to do, this is like u substitution. Cosine of 2u. Think about it that way. So when you do tonight's homework, and try that and see if you get anywhere. Because I made the video for this in the summer, so I kind of forgot what I did, but I'm pretty sure I did both ways for you. You can see which one is better. Oh boy, I forgot we have to do 8, 9, and 10. Okay, now I'm praying that we have enough time. Oh my goodness. Okay, look at number 8. Now, if you look at your book from last year, they have 8 more identities like on a different page. And you use those 8 identities to change products to sums and sums to products. Do you guys remember? I think there was a section in your book. I'm pretty sure Mr. Rubash said, oh, you don't need to know these. Yeah, you don't need to know them, but now you got to know how to figure it out, because this is really important in calculus. Okay, so we got some, why am I doing, I'm not gonna do the same problem. Cosine 3x. See how I just changed the numbers? This is how I make a quiz. I look at the problem, and then I go, how about cosine 7x? So right now it's a sum, right? How do you change this into a product? And why would you want to do that? Well, let's do it first, and I'll show you why you want to do that. Any ideas? Okay, I'll give you a hint. You got to use the average. What is the average of 3x and 7x? 5x. Okay, watch what I do. So I'm going to change 3x to 5x minus 2x. And then I'm going to change the 7x to 5x plus 2x. Now, can you see what's going to happen in the next step? Why is that going to be good? Do you guys have the foresight? Okay, let's write out the next step. Expand this. Cosine of the first, cosine of the second, plus sine of the first, sine of the second. Can you see it now? Some of you can, some of you won't. I don't know what foresight is. Cosine of the first, cosine of the second, minus sine of the first, sine of the second. What happens? These cancel out. Armadillo plus armadillo is 2 armadillo. So we changed a sum into a product. You guys don't seem excited about that. Now, if you don't like what I'm showing you here, then grab your book from last year and memorize those 8 more identities. And believe me, they're ugly, you know. They're not like simple, like double and half angle identities. They're like, you don't want to all you gotta do is just remember the average. It's easy. Now, why would you want to do that? Because, what if I ask you, solve this equation? See, you can't do it like that. But now, you do it like this. Now you can solve it, right? If something times something equals 0, that means either this one is 0 or this one is 0. Okay, do you guys even remember how to solve this? Is 0 a number I'm supposed to know for a cosine?
Yeah.
Okay, so cosine of what angle is 0? Oh,
Zero.
pi over 2 and 3 pi over 2. But remember, if it's 5x, you gotta go 5 times around. So you're gonna go around, 2 times around, 3 times around, 4 times around, 5 times around. Oh wait, and then now divide everything by 5. But you can't solve it when it's a sum. When it's a product, it's easy to solve. That's why I'm teaching you this, because you... Okay, now what about going backwards? Now, how do you change a product back into a sum? That one's a little more difficult. Okay, here we go. In fact, why don't we just do the same problem and just go backwards now? All right. So here is a product. Change it into a sum. Well, basically, you just go backwards. So if you have 2 gorilla, isn't that the same thing as 1 gorilla, leave a space, plus 1 gorilla? Everybody agree 1 plus 1 is 2? You're just going backwards. So if this is a 5, then this would be 5 halves and 5 halves then. But I won't do that to you. I'll give you 2. Okay, now you gotta think. I see cosine, cosine here. What would I have to add to cosine, cosine to make an identity? Sine, sine. See, that's why if you don't know your identities, how can? No can. So sine, sine. But then if you add it there, you have to subtract it here, right? To keep it the same as the original. Now, look at these two. Hey, you somebody. That's the identity for cosine 5x minus 2x. And then look at these. Hey, you somebody. That's the identity for cosine 5x plus 2x. And then now we just simplify. Cosine 3x plus cosine 7x. We changed the product into a sum. And again, if you don't like what I'm teaching you here, then memorize those 8 identities in your book from last year. Why do we have to learn this, Mr. Park? Just so teachers have jobs? No, because next year in calculus, you're going to have to compute the integral of this. You don't know what an integral is. But the only way you can do it is by doing this. See, this is hard. This is easy. Okay, last thing. The last thing, number 10 there. What if you have a sum of a sine and cosine function? In fact, you did it on homework when you did the graph. Do you guys remember what happened? Remember, wasn't this one of the homework problems? Nobody came in and asked for help on it. You guys did this? This is from trig 1. This was a problem. What happened when you graphed it? What happens when you graph a cosine function and a sine function of the same period? What happens? You get another sine or cosine function, except the amplitude got bigger. In fact, this is exactly how sound works. You guys know sound are sine curves, right? But if you add, okay, here, the amplitude is 1 here, the amplitude is 1 here. If I add these together, is the amplitude going to be 2? No, it's not. If you did the homework, I hope you noticed that the amplitude was not 2. The amplitude was about radical 2. That's what it was. How does that come about, Mr. Park? Well, I'm going to show you. Okay, I'm going to do a problem just like that. Okay, is that a minus sign? Okay, I've changed it to a plus sign then. Okay, in the interest of time, I'm just going to do either a sine or a cosine function. You pick it. Sine or cosine? Oh, wait. You know what, we've been doing a lot of cosines, let's do sine. Change this to a sine function. Okay, so what do? Well, obviously you guys didn't read the notes. You use the magic number. What? It's not really that magic, you know. But we call it the magic number. So when you have a cosine x plus b sine x, this is the magic number. Basically what it is, it's the hypotenuse of the right triangle. That's what it is. Okay, so in this problem, what is the magic number?
3. Oh, square root of 3, 2.
Yes, thank you. Everybody got 2? It's the square root of this squared plus 1 squared. 2. What do you do with that magic number, Mr. Park? You factor it out. That's what you do. So whatever the magic number is, you factor it out. That's going to be the amplitude. That's going to be the new amplitude. Okay, so look at this. Now, if you want a sine function, you got to know the identity. Isn't the identity sine, cosine, cosine, sine? Right? So we have to change this into sine. Okay, here, this is where you got to think. The sine of what angle will give you root 3 over 2? Pi over 3. Okay, and then I have to change this to cosine. The cosine of what angle will give you 1/2? Pi over 3. Hey, Mr. Park, it's the same angle. That's right. And if it's not the same angle, you can't use the identity. You got to make sure it's the same angle. And then now you go, hey, you somebody. Isn't this the identity for sine of? Okay, just tell me, what sign do I put here, plus or minus?
Plus.
Plus. But the rule in this class is you have to put the x first like this. So now you know, basically you take the graph of 2 sine x, and then you shift it pi over 3 to the left. So that's what happens. When you have a sum of a sine and cosine function, you simply get another sine function. So when you have, so again, let's see if you learned anything. If somebody is talking at 3 decibels, like this, and another person is talking at 4 decibels, they talk together, is the sound going to be 7 decibels? No. What is it?
5.
It's 5, because that's the magic number. That's the amplitude of the new function. See, sound engineering right here. All right. So this is the last lecture of this chapter, but you can see that there's so much stuff right here. I mean, there's so much material. All right. Now we are done. Woo!